All right, 2.2, day 2, analyze conditional statements. And we're going to be talking about biconditional statements. So a biconditional statement is when a conditional statement and its converse are both true, you can write it as one single statement. And we'll use the phrase if and only if. So write down this definition. When a conditional statement and its converse are both true, you can write it as one single statement. Use the phrase if and only if. Maybe underline that. Underline if and only if. Then we see right underneath that, for definitions, both conditional statement and its converse are true. They are equivalent statements. All right, let's look at some examples of this. So looking at perpendicular lines. All right, what do we know about perpendicular lines? All right, the definition is if two lines intersect to form a right angle, then they are perpendicular lines. The definition can also be written using the converse. If two lines are perpendicular, then they intersect to form a right angle. So the first one was our conditional, the second one was the converse, and both are true. So we can write that line L is perpendicular to line M, and we've got that little example there of L, and then the symbol for perpendicular M. But we need to write the definition of perpendicular lines as a biconditional. It's a biconditional, using if and only if. Let's see, do we have the lines on the other page? So we get back down to the bottom here. All right, writing our definition of perpendicular lines as a biconditional. So two lines intersect to form a right angle if and only if think of what the last sections should say. Two lines intersect to form a right angle if and only if they are perpendicular lines. So that's our biconditional statement. Two lines intersect to form a right angle if and only if they are perpendicular lines. All right, so we want to write the converse of each true statement, and if the converse is also true, we're going to combine the statements to write a true biconditional statement. So you'll recognize this one from the previous notes, this example from the previous notes. If your birthday is in July, then your birthday is during the summer. So the converse of that, if your birthday is in the summer or during the summer, then it is in July. And is that true or false? If your birthday is during the summer, then it is in July. That is false. So we will not write the biconditional, cannot write. Because the converse is false. So we have to have both the converse and the conditional being true to be able to write that biconditional. All right, number 2. If two angles are complementary, then their sum is 90 degrees. Well, that's true. We know two angles, or we know complementary angles add up to 90 degrees. So that statement is true. So let's write the converse of that and see if the converse is true. So the converse, we need to switch our hypothesis and conclusion. If this was P and this is Q, the converse, we need to switch and put Q first. So if the sum of two angles are 90 degrees, if the sum of two angles are 90 degrees, then the angles are complementary. Is that true? Yeah, that's true. So both statements are true. If two angles are complementary, then their sum is 90 degrees. That's true. Or converse of that, switching the hypothesis and conclusion. If the sum of two angles are 90 degrees, then the angles are complementary. So we can write a biconditional statement. We'd write it saying two angles are complementary if and only if their sum is 90 degrees. So two angles are complementary if and only if and only if their sum is 90 degrees. There's our true biconditional statement. Two angles are complementary if and only if their sum is 90 degrees. All right, the next one, our last one, we need to rewrite the biconditional statement as a conditional statement and its converse. So rewriting the biconditional as a conditional and its converse. So now we're taking apart one that's already a biconditional, an if and only if statement, and writing the conditional and converse. So our biconditional is two lines are parallel if and only if the two lines have the same slope. So our two lines being parallel would be P, and the two lines having the same slope would be Q. So in our conditional statement, it's if P, then Q. So we would say if two lines are parallel, then the two lines have the same slope. So that would be the conditional. If two lines are parallel, then the two lines have the same slope. Then the converse, we need to switch P and Q in the if-then statement, switching the hypothesis and conclusion, and say if the two lines have the same slope, then the two lines are parallel. So the converse, if the two lines have the same slope, then the two lines are parallel. And so both of those, the conditional and converse, held true. So we know we did them right, breaking apart that biconditional statement into a conditional and a converse. So that is it on the 2.2 day 2, analyzing conditional statements. Have a great day.